It's all Max's show. So my name is Robin, one of the founders of the program. Blue Stamp has now been around for our 5th year in our 5th city. So Palo Alto is brand new this year. We started off in New York about 5 years ago. We had no idea, honestly, what we were doing at that time. We just knew that we wanted to have more fun teaching education and engineering to people who were just curious about building stuff. So no test scores, no grades, no lectures, none of the textbooks, just making stuff. Screwing it up, getting frustrated, and just finding ways to persevere through significant challenges that face any design engineer in the real world. So that's where we started. Now we're here in our 5th city. We've expanded out to San Francisco, Houston, Denver, and still our New York program, which is the largest program in the country. So no further ado, I just want to say a few words to the staff. So Max Cormier is the lead instructor from Case Western. And to all the staff, really thank you guys for letting me enjoy this program in a way I never have before. So by them being so good at their jobs, taking on a lot of responsibility, really all of it from project selection all the way through today, just allowed us to just enjoy the experience with the students, not worry too much about things that don't work, because that's their job. So thank you guys, the staff. And let Max introduce the rest of the staff, and we can start short with the presentations.
Sure. So I'm Max, as Robin said. Walk around this way, so on the camera. So this is actually my first time doing Blue Stamp. I really enjoyed it. One of the biggest things I've noticed is that a lot of these projects are very similar to senior design projects I actually saw because I just graduated college. And it's just surprising that as high schoolers you're able to do it. I really wish that when I was a high schooler that I was able to do something like this. And really cool what you guys have done. And so I'm Max, I'm a mechanical engineer. I've tried to push your students, hope they've enjoyed that and tried to learn from that. We also have Milena back there, electrical engineer. She definitely helped out with your students who are having trouble with circuits because she's done the best with that. That is definitely one of my hard suits. And Hannah as well, programming.
You guys want to go up and
so yeah, so this has been definitely a great experience, and I hope your students have enjoyed it as well. And so this is the list, as Robin said. Please feel free during the break to get food, ask questions. We tried to make sure that the students were learning as well instead of just plugging stuff together. So please ask questions if you have questions. So Hannah and Milena, do you have anything to say?
Hi, I'm Hannah. I'm from Taiwan. I go to school in NYU since this year, and I'm in the field of computer engineering. So I mostly help students with their problem in coding, and I'm very enjoy this camp. I learned a lot from the students, and yeah, I'm very happy to work with them this summer.
So hello everyone, I'm an electrical engineer. I'm doing my master's in electrical engineering back in Europe at Columbia University. I'm from Brazil, and this is my last semester now there. And it was a really great program. I could learn a lot, and I'm really happy that I could help him and see today all these projects working and how they could be more confident doing this hands-on projects. And I'm happy to share with you this experience. Thank you.
Yeah, thank you. So without much further introduction, let's start with Karina, who wants to talk about her EEG.
Hi, I'm Karina. I'm a senior at Castellet School. So for my project, I decided to create an EEG. So what an EEG does is it monitors brainwaves, and the specific signal that my EEG that I designed is alpha waves, and so this picks up only alpha waves, and there are specific filters and amplifiers that are designed to pick up waves within that section, which is from 8 hertz to 13 hertz. And so the circuit begins with an instrumentation amplifier, which is right here, and it then goes to a 60 hertz notch filter because there's a lot of fuzzy signal from the power line, which can disrupt the actual data that you're receiving. Then it next goes to the 7 hertz low power filter, which drains any noise from the skin that's kind of just like picked up across the head. And then it goes through a 31 low pass filter, 31 31 hertz, and so it basically gets rid of any noise above 31 hertz. And then it goes through another 1 hertz high pass filter, and then another 60 hertz filter, and then it goes into the computer. And so on the computer, I used a code that was given to me in processing, which helped me display the waves received from the signal in this circuit. And I had a little bit of trouble, or actually not, I had a lot of trouble configuring the certain program because it had a lot of different aspects that you had to go through to making sure that it was specific for your computer and the circuit that you built. I also had trouble picking up the signal as my computer did not have a microphone input, and so I had to purchase like a device that would allow me to do that, and then I had to program the processing code to receive data from that specific port. So I'll show you how it works. We have this electrode gel, and you put it on the electrode like this. And then this cable is an input 2 from the first instrumentation amplifier, and that can go either on the forehead or on the back of the neck. So I'll just put this one here. And then this next one is another input on the instrumentation amplifier, so it can go on the back of my neck. And then this last one is the ground, and so that one has to go behind the ear. As you can see, it's really flawless of a design. Yeah. Awesome. I think I put too much electrode gel on the forehead, so we'll see how that works. So I don't know if it's on. Oh, I have to actually drag this. There. Okay. Okay, so that happens. That's 1 second. Let me just hold that. So I put too much electrode gel on the forehead, so I'm just going to actually use another electrode. And I don't think we need the electrode gel. There's already a lot of excess on my forehead. So as you can see, I'll pull that up. So that's the brain signal that it's picking up, and yeah, so every time I blink, it kind of bounces. It usually has more waves, but these are not that well hooked up because, yeah, I didn't do a really graceful job of that. But when I blink it, you can see movement there, and when you concentrate, there's also a lot of movement. Yeah, that's my device. I had, as I mentioned earlier, a lot of challenges with the processing code because it just was really, really technical, and I never worked in processing before, and so I had to do a lot of reading and debugging of the code to kind of figure out where it was specifically that the signal was being lost. And so that took up a good amount of my time. And I also had a little bit of trouble configuring the actual circuit, as the schematic was hard to understand, and so I spent a lot of time kind of configuring and reconfiguring that using different diagrams of the different op amps along the circuit. And I had a lot of really, really great help from Melina. I would not have been able to understand the circuit in the way that I did if it weren't for her. So that was really great. And I think if I were to have more time to finish this circuit, I would probably use Java to read some of the Java allows you to add more inputs and more electrodes around your head, so you have just a lot more data that you're working with. And I overall thought that this was a really great learning experience. I chose this project originally because I'm really, really interested in neuroscience, and so I wanted to kind of understand what it was behind these specific machines that we're using that allows you to read this data and actually understand something from the brain, and so that was kind of why I did this project, and it was really helpful for that, so yeah. Project.
Any questions?
What would you expect to see? Would you expect a flat or?
Yeah, so that's actually, I did see a little bit of that, but if I had more time to test, I really, really only recently was able to have any success in picking up signal. I read a lot about it, and it appears that it would be more of a softer wave, but that would be a part of my next steps if I were to continue.
Now that you've done the whole thing and had all that heartbreak and worry and everything, are you glad you picked the project?
Yeah. This is exactly what I'm interested in, so I thought it was really important that I actually spent the time figuring out what it was, kind of making these things work.
So what's the next step you're going to do with this project?
I would probably start working in Java to kind
Add
of,
more input?
yeah, have more inputs and actually put data and compare it with each other and stuff across different parts of the brain and be able to actually read different waves, because this was only specifically for alpha waves, and so I want to try to read other waves.
Thank you.
Well, thank you. Next up, we have Elliot. I'll grab some more chairs for you guys at the back, so please feel free to sit down. Grab some food while you're back there. Yeah. Also, feel free to sit closer to the front. There's no reason to be scared of the speakers.
When you are
are you speaking? Thank you for sitting still for a while. Just trying to get everything set up.
So hello guys, my name is Elliot and I'm a rising senior at Burlingame High School, and my project was the smartwatch, and so as you can see here, as you can see here, it is there's three main components in my Arduino smartwatch. There's the OLED screen, the Bluetooth, and the Arduino itself. And so what it basically does, it takes notifications from my phone, and I'm able to send data through that using my Bluetooth, and it displays the notifications on my screen. Something I had trouble with was that I couldn't fit everything, or I had trouble putting it on a smaller Arduino board because I had some technical difficulties. And so here I can show a demonstration of it working. Right here on my board. So right now it's not connected to my watch, and well, it's not working right now. Sorry, it's not working right now. But yeah, so well, it would display the time, and I have a button right here, and what it usually does is like I can click through it, and it would show me the notification that I have on my phone. It would tell me like what percent my battery's at, and it's pretty useful. And another thing I designed was the watch case. You probably saw that earlier. The watch case was a challenge in itself. I had designed multiple watch cases, and this is one of my prototypes. If you guys know, yeah, so this is my prototype right here. And one thing is that it's a bit too small, and some of the watch features that I cut out were a bit small, so I'm going to have to fix that. And that's one of my next steps, is to fit everything under this watch case, and also add more functions to my watch, such as an alarm. And I guess the biggest challenge for me was the challenge I'm still trying to tackle, is to fit everything underneath this watch, because as you can see here, I have this, well, my watch that, there's a smaller Arduino board that I have, and I'm having some technical difficulties having the button to work properly, and it's something that I need to fix, and hopefully I could get it working tomorrow or in the future. And reflections, I had a great time here. I previously didn't have much experience in engineering, and this watch allowed me to get experience in electrical engineering, mechanical, and even designing the watch case was pretty fun. Like I knew a little bit of 2D CAD beforehand, but doing 3D CAD was really fun. I got to think in different dimensions, and yeah, I had a great time. You guys have any questions?
What were your biggest learning?
Biggest learning? Well, I would have to say is getting all the pins connected together. I'd never worked with Arduinos before, and I learned a lot about how there's like digital pins and then there's analog pins, and I mainly use digital pins because it was easier to use, and yeah. Mark?
Did you say so with the watch thing that you designed afterwards,
Yeah.
is the Arduino going to be like attached externally, or are you going to use
It's all going to be internal.
Oh,
It's
really?
all going to be in the watch case, yeah.
What's the battery life?
The battery life, I have a 150 milliamp battery, so that could last 7 hours. on a normal charge. Yeah, with normal use.
You happy with this project?
Well, previously, I wanted to get into the watch case before today, but it's something I was not able to finish. But hopefully I can get it done tomorrow, and I'll be able to shoot a final video for it.
How do you plan to take market share away from Apple? Just thinking ahead, but I think it'll work.
Yeah, thank you.
Alright, next up we have
Hi everyone, I'm Vijay and I'm a incoming sophomore at Limburg High School. So for the past 6 weeks, I've been working on this. It's a three-wheeled omnidirectional robot. So it's similar in a way to an RC car, except the wheel orientation is different and the type of wheel is different. But I'll go into more detail about that later. So as you can probably see on this robot, make sure you can see, many types of engineering are needed to make this, such as the electrical engineering, modeling, and definitely software. As you can see here, the different components I have on this robot. Well, first, I have the hexagonal wood base that I cut out. I have 3 servo motors here. I have an Arduino, 3 Omni wheels. Yeah, so the 3 servos are getting code that is uploaded into the Arduino that's making the wheels rotate. So now I'll give you a live demonstration of how this works. Here. Bring it up.
We're just driving down the aisle.
Right. Alright, let's see if I can throw it. I'm working on my learner's permit. Thank you. Okay. So, next steps for this project. Well, in my toolbox, I have a couple extra bars. With those bars, I want to mount them to my hexagonal base, and then cut out another hexagonal base, and then mount the hexagonal base so it's skewed to this hexagonal base. And the purpose for this is so I can place objects like that. And like if I'm sitting down in my house and like I'm really lazy and I don't want to get up and like get the object, I can just like use my PS2 and like bring the object to me. Yeah, that's a good idea. I think the greatest challenge for me, I would have to say, is perseverance over the past 6 weeks. Because even today, even a couple hours before the showcase, my PS2 receiver was having problems interfacing my PS2 and my PS2 receiver. So basically, my robot would start, but it couldn't stop. So that was a problem. But I'm glad I did persevere, because if I didn't, I definitely could not have this robot here. As reflections, yeah, I think going to this camp really gave me the motivation to pursue some type of engineering, because I like all of them. I mean, it's really interesting. But this camp really motivated me to pursue some type of engineering in my future. And I'd also like to take this time to thank all of my instructors for helping me along the way. If it wasn't for you guys, I couldn't get this robot. Yes, that's it. Thank you. Questions? Anyone?
Would you pick Omni wheels for your next robot?
Yes, I would.
Why?
Because Omni wheels allow my robot to move a lot easier than if I use different types of wheels. Yeah. For example, even with the turning of this, because I used Omni wheels rather than regular types of wheels, I just had to rotate each wheel either clockwise or counterclockwise to turn. So in that sense, Omni wheels are easier to work with than other types of wheels. So, yeah. Thanks.
So next up is
main project, the sound digital light show circuit. So this circuit uses Arduino mainly, and it's powered by two 9-volt batteries that power the main components of the circuit. I use a microphone to take the sound input and then translate that into electrical signals that the circuit can understand. And those electrical signals then pass through a series of operational amplifiers which increase the voltage difference. And since the microphone signals are very weak, so the circuit needs to understand it clearly. So that's why it goes through the operational amplifiers. And once it goes through those different filters, it then goes through the Arduino, which I have coded to interpret those electrical signals, to interpret whether to turn the LEDs on or off. And I've also coded in a slight pulse. And that pulse on the LEDs is mainly in part by pulse width modulation, which is a function that varies the amount of time an object is receiving voltage and not receiving voltage. And so here's a demonstration of it. That's how it works. And so my next steps for this project are putting it in a wood box and then possibly moving the whole circuit to a printed circuit board so it can look less wiry. And then, and then my greatest challenge, I would say, was making the code for the LEDs work, and because that was really hard to make them light up when the certain sensor values would be enough to trigger the LED to turn on. And I also learned that engineering is a key part, perseverance is a key part of engineering, and because there's going to be obstacles and you just have to know that eventually you're going to get through it and it's going to work. It might take a while, but it'll get there. And and I just really liked this project and I thought it was really cool, so thank you. Any questions?
So you're planning on adding a lot more lights to it?
Yes, actually, I want to add, I can possibly add up to 3 more LEDs, and so I can make the light show even more fun. So, yeah, it's really cool.
There's not a spot for it. No. Hi everyone, I'm Laurel, and I am a rising senior at Castleton School. And my main project was an EKG. I chose this because I'm really interested in biomedical engineering. I originally was really interested in medicine, but didn't want to commit to the debt in many years of school. And I also really like building things, so I thought this was a great mesh between the two. So I first started by making my circuit on a breadboard, which is something you'll see in some of the future projects, but it's has an interesting configuration with different lines of conductivity. And so I got that to work, but still I had a lot of challenges along the way. So when I first hooked it up, well, first, an EKG is something that it measures your heart rate and it'll tell you your beat per minute. And so I configured it to say I'm alive, and then give you the little the beats per minute, or you're dead, and then say less than 30 beats per minute. But along the way, I had to struggle with it not working. So I realized that there's a voltage regulator, and that needed to be emitting a negative voltage instead of a positive one. So by switching outputs and grounds, I finally got a negative 5 volts to be released, and that in turn made my circuit work properly, which is very exciting. So I guess I'll give a demo of this first, and then explain why I can't show it to you in person right now. Okay. Oh, so I have to drag it, right?
Yeah.
Drag to the right.
What am I doing? Which is why I'm not going to be a computer engineer, I'll tell you that. Okay, now the screen's gone.
Grab the top.
SOS. Oh, sweet. Okay, cool. So, so like, okay. This is right. Okay. Oh, what's that here? Sorry, I'll turn the thing up.
Right now it says I'm dead, which is good for this test because I'm not plugged in, showing that the EKG is working. Now I will plug in my electrodes to the 2 inputs of the first IC. So right now you can see the LEDs blinking with my heart rate. And now I'll plug in the speaker. And the speaker will also beep in rhythm with my heartbeat. So right now, the LCD screen is reading that I have a heart rate of 80, now 99. And it says I'm alive, which is very exciting. So next, I will create my own oscilloscope. Thank you for watching.
Okay, oh, wow. Okay. So, from there, I moved on to create my own oscilloscope, which is shows a visual display of the heart rate as waves, something you can see if you ever go to the doctor and you have an EKG. So I went to make that with a kit. However, all in all, it turns out that the kit itself was missing some pieces. So something I learned from that was that you can't always trust information or products that are handed to you, and you really need to like check with your own knowledge and abilities in order, like, before trusting anything that's given to you. So in the future, I hope to get another kit and make it work. But this is what it would look like if it was working. So instead, I went to transfer my circuit onto a perf board from my breadboard. So I spent the past couple days on that. A perf board is more professional, more compact. Sadly, it is not working at the moment, but by tomorrow, hopefully I'll have it all done. But I think I learned a lot about perseverance in the process, like Chris said, and just rolling with the punches, and nothing in engineering will ever work on the first time. So just being happy with whatever is thrown your way. Let's see. Oh, so in the past, in engineering, I had taken some classes and I had done basic engineering and electrical, 3D printing, mechanical, but what was really interesting for me was combining all of it into a single project that could function in a way that I wanted it to. So I think that was a great challenge, kind of intersecting all the different fields and majors. So that was something that was very exciting for me, and I learned a lot in the process. Thank you. Any questions? Thank you to all the instructors, by the way. Melina was a huge help. Yes, Max?
So now that perf board is professional and not working, are you still glad that you want to go more perf board and more permanent?
Yes, I think something that's really, well, something that I value in engineering is actually having something that you can put out into the market, because I don't know, I have a business mind, so I want to make some money, I want to get things going. So I think like aesthetically getting things to look professional and nice, something important. That's why I want to 3D print a case for this as well, in order to really get people to use it, because basically even if your like technology is really cool, no one's going to buy it unless it looks cool. So that's something that I really want to look into more in my free time. Any other questions? Thank you.
Yeah, I do have one. So, since you have a business mind, so you're thinking that like somebody would want to just pick one of these off the shelves and have them to bring home, or what is your idea?
Well, I think in the future I would go for something that wasn't like kind of from, not, this wasn't from a kit, but not something that was so like, here are the instructions, this is how you make it. I would like to do something more organic, but I think for this, I've had people in my family and like extended family that have had heart problems, and so it's kind of reassuring to be able to check yourself and see, okay, everything's fine right now, even though I'm feeling a little eh. So I think it could be something useful. It may not be as accurate as the ones that they have in the hospital. Hopefully it isn't, I don't know, who knows. But I think that could be really interesting to have as a handheld thing. I know a lot of people are buying blood pressure machines. So I think the industry is leaning towards like medicine that's more accessible. So I think that could be something interesting to see in the future.
Next up, Vincent.
Hi, my name is Vincent, and I'm a rising sophomore at Limerick High School. And my project is a remote-controlled car with a robotic arm. And so this controlled car is controlled by a PS2 controller. And I connected the wireless transmitter to the Arduino so it can communicate with the Arduino. And I also connected a motor shield to the Arduino so it can also control the robotic arm. So the design is two wheels on the back and one caster wheel in the front, so we have like balance and robotic arm on the back, so the front's not taking too much of the weight of the arm because it's quite heavy. I can first demonstrate the arm. What? Yeah. I can open and close the fingers right here. So now, after I demonstrated to right. So it curves to So a few problems I had with this was definitely getting the wireless to work with the Arduino, because I had no experience with that at all. So I had to go in to the like deeply into the instructions to figure out the pins to connect and the code, so I could program this to work with the control the motors. And another problem I had was trying to get the motor shield to work with the Arduino and powering both the motor shield and the Arduino, and to program the motor shield so that the wireless also works with this robotic arm. And another problem I had was getting this to be on the robot so it can like drive around. And at first it was going a little bit slowly, but then I discovered that the caster wheel was locked. So it's like a student here locked it. It went a little bit slow. Then after I unlocked it, then it went like fast as I expected it, faster. So I learned from this. I learned a lot about coding in Arduino and wireless communications in general. And I guess this camp really taught me a lot, and I had really a lot of fun here.
Why did you choose a caster wheel?
This caster wheel is easier to like navigate around because it's rotating. So if I had two more wheels here, then it wouldn't be as convenient.
Next, we're going to have Alex with his hovercraft.
Okay, so hello everyone, my name is Alex. I'm from Wheeling High School. My project is a remote controlled battery. Just kidding. This is my project. This is a hovercraft that I've disconnected the battery to. So how this thing works is I have a motor in here, which is connected to this battery now. And what happens when I turn this on and turn on the battery is this motor pushes air downward and it actually inflates this green skirt. And this whole thing rises up in a cushion of air and essentially floats on top of the ground. And as much as I wish it could fly, I'm afraid it can't. I tested it and it doesn't fly at all, to my disappointment. But it does float really well, so that's a bonus. Now, I also have a motor in the back for propulsion purposes. And I have spent a lot of time on this. The most difficulty I had was with the electronics, which took a few weeks to perfect, or actually get working. And I would have spent more time in class working on this and testing and playing around with it, but if I turn this on, nobody else can work on our project. And if I turn this on, I'll show you exactly why. Now, also, steering this is really hard. Okay, that was a bad mistake. So steering this is really hard. Imagine driving a car. Now stop imagining that because it's nothing like it. Oh, I messed up again. But even turning this on is a much harder task than turning on a car, as you can see, because I've messed up at least 2 times. Now, I can't steer this at all. I tried, and all I did was make it drift pointlessly. So I'm just going to kick this down the middle. I would show you driving if I actually could, but if I tried to drive it through here, it would get stuck in that chair. So I'm not going to do that. Thank you, Max, for turning it off, otherwise it would beep. And so next steps, I want to give this thing autopilot, but that's incredibly hard because there's a lot of electricity and electric parts involved, and it's really annoying to work with. Thank you, Max. No problem. And as I mentioned before, the most difficulty I had with this was the electronics, because I've actually gone through about 2 or 3 batteries now. First, they were too weak, and then the second one I burned out because I charged it for too long. And now I have my 4th battery, which is the one I have right here. And even though it was a real struggle in the electronics phase, because if I tried to make the motors run, all it would do was beep for half a minute and then not work at all. And even though that happened, it was really frustrating. I eventually got it to work in the last 1.5 to 2 weeks. And I am glad I chose this project because I have had some experience with computer science programming, but I have not had any experience in mechanical and electrical, and this let me design the entire thing from scratch, except the electronics, I ordered those, but this entire thing I had to make from cutting out styrofoam, gluing it together, and covering the entire thing in really bad colors, fiberglass. Yeah. Any questions?
How do you design the skirt?
I had a lot of sewing involved. There was a lot of sewing involved. It was like 2 days of sewing. And I think I cut myself a lot. But this is a design I found online for, and this is not the only type of skirt. There's another one that's got a lot of fringes on it, but that would require about 10 times more sewing, so I decided not to do it. Max.
Looking at the hardware design, is there anything you would have changed about it?
It's a little big. So I would have probably made this shorter because as it is now, to keep it balanced, I have a nest in the front, and every time I put in the battery, I have to shove it inside, like you saw me do earlier. Otherwise, it's going to tip to one side and not move. Yes?
Any plans to make one large enough to hold yourself?
No. First, I doubt I can power that with this motor. As for those, there are already kits you can buy online for under $1,000 for those. And I think it'll be a lot less difficult than making one on my own and having to deal with the same electronics problem on a much larger scale. So I'm going to pass. Any other questions? No, thank you very much.
Alright, I just need to connect my computer here.
No, I was talking to my mom.
Can I hear about it? Alright. Perfect. Alright, so good evening everyone. My name is Mar. I'm a rising senior at Evergreen Valley High School. And my project is called FluxPlant. It's a cloud-based water monitoring system. Try saying that 5 times fast. Now, so the way I got interested into this is basically, as you all know, Californians here are going through a huge drought. And at the end of every month, you get a bill at home saying, oh, you've used this much water. This is what normal people use, and you're up here.
and then you look through all your things. Okay, you know, mom's been using the shower more, or oh no, it's his sister, or it's my dad, you know, and there's that whole fight that's going on, and you don't really get to solve the problem. And there are solutions out there today that allow you to track different faucets and stuff like that, but they're huge systems, and you know, they require monthly fees and stuff like that. So I decided to go out and solve that issue. So my project has 3 main components. So for the first part of my project, I used, sorry, let me just start on the break. Okay, all right. Yeah, so the first part of my project was basically the sensor itself, which would track the water usage in your house. And so this is basically simulating 2 pipes, and this is a fluid sensor. And so basically as the water flows through here, my circuit will record how much water you're using. And while it's doing that, it's also going to record the temperature, and I'll let you know what that's for later. And basically what this will do is also send it over the web to the server that I've created online. And so, and then after I designed this, I built my server and my web application. So let's go on this. So hold on. All right, so I'm going to sign in with Google+, Facebook, and you know. All right, so let me just go to the front page. So this is like the front page of what your web application would be. It gives you a lot of aggregated data about how much water you're using. It puts in some nice graphics, basically showing how many gallons of water you used, and you know, how many water bottles. Same sort of thing with the cost. Now I'm not a graphic designer, so please don't laugh. But yeah, and well, this actually is not on the actual server, but you would see smoke billowing from here, and the more carbon emissions you have, the more smoke there would be. But yeah, so these are just the kind of features that are on my application. You can go through different graphs and see different data of how much water you're using. This is just mock-up data to show a month's worth of water usage and water tracking. So yeah, that's my application. And so the interesting thing about this is, right, the way I designed the server is that it allows for this application to be used with any sensor. So I created a public library for any sensor to be able to send its data to this server, and that way it sort of eliminates the specialized use of one sensor only and one company to one application. Anyone can upload their data, and anyone can track their own water. And this can be applied to any sort of sensor that you would that could be applied. It doesn't have to be the ones that are intrusive and you have to connect 2 pipes with. And so the benefit of that is that you know, you can have multiple sources and you can get good analytics with it. So this product has been a long way coming for me. I started this with just this part, and I looked into the web application part, and I immediately realized I was way in over my head. It was a tremendous amount of research and learning for me. I had some programming experience, but just at this scale was definitely a challenge. But it definitely gave me a lot of perspective as to what sort of field I would like to go into later for engineering. You know, going into things like data science and working with Internet of Things sensors, right? It's a lot of interest to me. So future plans for this is now that I've created the web application, I'll be expanding it more, adding more features. My main thing is now, instead of having a sensor in between 2 pipes, I can have one that's non-contact and then she can put on any pipe without having to unscrew things and bolt things on. It would be like a sticker that you just tack onto any pipe, and it will track the data and send it to the web server. And I really see this as something that can be a commercial application one day. Obviously, I have a lot of work to do, but definitely I'd like to explore this area more and expand my programming skills at the same time. So yeah, definitely looking back, BlueStem has been an amazing experience for me. Thank you to all the instructors. Dealing with all my code problems and me sitting in a corner just typing away on my computer. So yeah, definitely it's been a good experience. Do you guys have any questions?
Do you know what type of sensor you're looking at? You say your sticker.
Yeah, so let me be more specific. So the sensor that I was talking about would be an ultrasonic sensor, and basically what it does is, on a pipe, it sends ultrasonic waves through the water, and it would sense the delay in from when you sent the signal and when it came back. And the longer the delay is, the more water is flowing through the pipe. And so that's the sort of data that I would work with, and it would be a very convenient application for normal consumers who don't have the time to unscrew balls and install it in their thing. It's very easy. You just tack it onto any faucet, and it would send the data there.
That's wireless?
Yes, it would be wireless. Yes, yeah. So you'd have a central home unit that collects all the data, and the sensor itself would just send it to the central home unit, and then the home unit would package it all up and ship it to the server.
So you would have sensors for each place where walk, you know what I mean? So like in your kitchen.
Yes, yes. So that's the general idea, because I mean, your water bill, or at least, I mean, I don't know, from the water bill at my house, it's just an aggregated data of, okay, this is your total water usage for the month. That doesn't really tell you where you can conserve, right? So it's good to pinpoint different locations in your house and see, okay, oh, Amar's been using the shower, an hour longer than he should be, or something like that, things like that. And the temperature sensor, sorry, I know I'm going over time, but just really quick, the temperature sensor looks at the temperature of the water, and it can also tell you if you're heating the water or not, and you can also factor in carbon emissions from that as well. So you basically, the possibilities are endless. The platform is designed so it's modular, so you can easily add things on, tack things on in the end, and display all the data as you want it. So that's how it's sort of designed in the base. Any other questions?
Well, thank you. Feel free to stand up. We're going to take a quick break. Grab some food. There's plenty back there. Grab something to drink.
Hi, my name is Tiger, and I'm a senior at Mills High School. I want to first show you my starter project, which is the TV decon remote. It sends a series of infrared signals to the TV to turn it off. And I have a fun story that I want to share with you guys. So I basically bring this everywhere I go now. I just think it's so cool. I leave a trail of turn off TVs. So one time I was in Yosemite, and there were at least 100 people watching the women's final soccer game. I was so nervous. And I turned the TV off. Everyone was yelling at the waitress, telling her to turn on TV again. I felt really bad afterwards, but it was great. Yeah. Okay. Now I'm going to show you my main project, which is the robot, and this is called the tabletop robot, and this is called the Me Arm. This is version 0.4. And it is all controlled by my PS2 remote. And I will give you a demonstration. Okay, now it works. Okay, so I decided to move left, right, forward, backwards, and now here's the arm. I will close the arm, open the arm, forwards, backwards, and then I will move the arm down, move the arm up, and then turn. So the reason why. So the reason why I chose to build this robot is because I'm an active member in my school's recycling club. It's called Green Youth Alliance, and I really want to have a robot that can pick up trash. And I'll show you that it is strong enough to pick up marker caps. So it's really only it's strong enough to do that. But if we have a marker cap infestation, okay. And so my biggest challenge for this robot is that is connecting this controller to the receiver right here. And I spent about 2 weeks being frustrated, not making any progress at all. I asked Max questions, he told me to figure it out. And what I mean by that is that this program really doesn't try to baby feed you all the information you need. Like they try to guide you to the answer you're trying to look for. So by the end, I really learned a lot. I think I know everything about PS2 controllers now. I'm not to brag, but I also learned to laser cut. I laser cut this arm and build it all by myself. I use Inventor, which is the program to design 3D objects. I designed these and 3D printed them right here, and that's about it. And lessons I learned. Going into this program, I really had no knowledge of engineering. I think the most knowledge I have is like for Legos. I think that's most engineering knowledge. And I think that I've learned so much here. I learned about programming, mechanical engineering, and I learned so much from the lectures here, like solar panels and all other cool stuff. Yeah, that's it. That's my robot. Any questions?
Any thoughts to the redesign of the arm to make it stronger?
Well, yes.
How?
Huh?
How?
Getting a better servo. I think. Oh, I forgot something. So for my future plans, I plan to make a secure case to secure these two things. Right now it's secured by tape. It's not very secure right now. And there's also a balance problem right here. It's if I try to drive it while the arm is fully extended here, it will flip over. So I want to install more counterbalance at the back. And that's it. You can continue on with the questions.
Any idea to integrate your TV remote control with your robot?
If I turn this into TV, I guess. Yeah. Okay.
Can you make a remote that comes off computers?
That's a lot harder. The only reason why this works is because most TVs in North America have the same component in there where you can be hacked into, and computers are a lot more different. So, yeah.
What kind of the smartphone?
Smartphones? That's even harder too. Yeah.